All right. So for the next one, we're just asked to solve a quadratic, which is negative 4x squared is equal to 5x plus 9. And so the best way to solve quadratics is first you want to make it look like this: ax squared plus bx plus c, and set it equal to 0. In just about every scenario that I can think of, that's the best way to solve a quadratic. So let's do that. So I'm going to subtract 5x from both sides. 5x is not, I got to adjust the sensitivity of my little stylus here, is not a like term with the x squared, so this just becomes negative 4x squared minus 5x. Over here, 5x minus 5x equals 0. 0 plus negative 9 is 9. To move, wait, did I write? Oh, in the original problem, it's plus 9. So now I'm going to subtract 9. So I got negative 4x minus 5x minus 9 equals 0. Now, what I like to do if I have a graphing calculator is I like to put this in the graphing calculator and see. So I'm going to, on a standardized test or a final exam, when you don't have a lot of time, one of the things that you should probably do, and I'm going to move this out of the way so I can see it, and I'm going to pop this up. Let me make this big and move my face over here and then look at the display. Oops, I don't want that. I want to view this. No, I want to view, what do I want to view? Oh, okay. No, this is the right one, but I don't want to view this. All right. So if I go in here and I graph this, I solved it, and I graph it. Remember that we're solving for the 0. So on quadratics, we're solving for a 0. That means when y equals 0, which is here. So notice that the quadratic function does not cross the x-axis. Immediately, I know there's no real zeros. Immediately. I'm going to do a bunch of math to prove it. In other words, it's going to be a complex solution. Another thing that I could have done is I could just graph the left-hand side of the equal sign, which would have been negative 4x squared, and then the right side of the equal sign, which was originally 5x plus 9. If I graph this, I notice that the right-hand side never, ever crosses the left-hand side. And if I zoom out, it just doesn't happen because this red line keeps going this way and the blue line, they never cross. So there's no real solution, okay? In other words, if I do this method where I take the left-hand side of the equal sign set it equal to the right-hand side of the equal sign, and I graph both sides, the intersections wherever the graphs cross is going to be the solution. And since they never cross, there are no real solutions. So right in the very beginning, I know this thing is no real solutions, which means with regards to a quadratic, what did I do? Oh, I grabbed the wrong pen. I got too many tablets. So immediately I know there are no real solutions because there just aren't. Well, how do I know that? Well, what we're going to have to do is we're going to have to use a quadratic formula. Remember that the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So if there are no real solutions, that means there are complex solutions, which means there are imaginary numbers. And the imaginary numbers occur. In other words, I is equal to the square root of negative 1. So that means when I go to do the math, and we haven't talked about this yet, but this part right here is called the discriminant. And I'll teach that later, but we haven't reached that point yet. But when the discriminant is negative, that means I'm going to have a negative square root. That means I'm going to have an I, which means I have a complex solution, and it only occurs when there are no real solutions. And graphically, what that looks like is, the two graphs that I showed on the computer, okay, or on my computer, but on the graphing calculator. So let's crank through the math. So first and foremost, we need to know A, B, and C. So if it's written in this form where A is the term in front of the x squared, B is the term in front of the x, and C is the constant, but it has to be equal to 0, then I get A is equal to -4, B is equal to -5, and C is equal to -9. So with that information, I'm going to plug and chug. I'm going to plug those values into the quadratic formula. And I would write this down in your notes because you're going to need this. I also have a video, and I'll post that in the thing. You can program the quadratic formula in your calculator. We did that in class, but I don't know if your calculator has that installed automatically. So you might want to review that video too. Anyways, so I get x equals negative b, but b is -5. So wherever there's a b, I'm going to plug in a -5. Plus or minus the square root of b squared, which is -5, squared minus 4 times a, which is -4, times c, which is -9. All over 2 times a. 2 times a. So in the next line, I've got x is equal to +5 plus or minus 25, the square root of 25. And -4 times -4 is +16. +16 times -9 is a -144. All over 2 times -4, which is -8. So then I get 5 plus or minus the 25 minus 144 is -119, all over -8. And so that means that x is equal to 5 plus or minus the square root of -1 times the square root of 119, all over -8. That means that 5 plus or minus, that's equal to 5 plus or minus I, right? Because remember that I is equal to the square root of -1 times the square root of 119, all over -8. Now, if you look in your solutions, there'll be something similar to this, but it doesn't have I. Don't be fooled. Okay? That is what it is, but because it has I, it's complex. And because it has a complex solution, remember I said it's a complex solution, then it's very important that you understand that there are no real solutions. So, no real solutions. So I would write everything that I have written down here in your notebooks, open book, open note test. The problem that you're going to do on the real test will be the same exact problem, except the numbers will be different. A will be like -3, B will be like 2. And I'm not saying this is the exact values. It'll just be different A, B, and C. So when you have a different A, B, and C, the process is the same. You got to do all the math, but you're going to end up with a negative here. They rigged it up that way. So that means you're going to have an I. That means you're going to have a complex solution. And that means there's no real solution. That's it.